All right, good morning, everybody. Welcome back to PreCalc. And it looks like snow is going away, so that's a good thing. So I think we shall start with an equation like this and see if we can solve something that looks like this thing. Okay, log 8, log 8. Okay, so these are both the same. Draw. I wish my screen was just a little bit bigger for this. All right. So what we have here is we have, this is a good problem because it's, if you only got to the point where it says you can't take the log of a negative number, this one is going to confuse you because your answer, I think, is going to be negative. If you don't know to go back and check, it's not going to work out so well. All right. So let's go ahead and do the usual thing, right? Because we have to get one log on both sides. So what we're going to do here is we are going to push these together with our rule, right? We have log of AB is equal to log of A plus log of B. So these guys are going to come together. So we have log base 8. We have 7 minus m. I'm just going to swap the order here, minus 5 minus m. Okay, equals 2. All right. So what I'm going to do next, I'm just going to multiply these together. There's a couple of things we could do at this point, though. I mean, it wouldn't be wrong to factor a -1 out of this and to factor a -1 out of that and then work it that way. That's probably the best way to go. So instead of having me do that, let's go ahead and say this is log 8. We have a -1. So it's going to change that sign. So I have an m. 7 is going to change to a negative. Let's pull out another -1 here, and then we'll make this an m plus 5. Okay. Now remember, when we go to check, we have to go back to the beginning. All right. But as we're working it, it's okay to, to rearrange things as you're going to have them see fit. So this -1 and this -1, that's going to make a positive 1. We have log 8. We have m minus 7, m plus 5, and that's equal to 2. Okay. Let's go ahead and multiply this thing out. So we have log 8. That's going to be an m squared. That's minus 7 plus 5, so it looks like a minus 2m. And then we have a minus 35 is equal to 2. All right. Now we have to unlogify, right? We have to take the anti-log of both sides, which means we're going to make these two sides the exponent to a new base. We're going to pick 8. Why 8? Because the log base 8 is telling us why to pick 8. Okay, if it was log base 12, we'd pick 12. So we have m squared minus 2m minus 35 is equal to, it's not 8 times 2, it's 8 squared. It's equal to 64. Okay, so be real careful about that. We're going to subtract 65, or 64 rather, from both sides. And it looks like we're going to have m squared minus 2m. And this looks like it's going to be minus 99 is equal to 0. Okay, so I need two numbers. When I multiply them together, will be 99, but their difference is going to be 2. So I think what we're going to do is we're going to say this is m minus 11, and m plus 9 is equal to 0. Let's double check. So that's minus 11m plus 9m. That gives me minus 2. 11 times 9 is 99, so we're all set. So by zero factor principle, we know m minus 11 equals 0, or m plus 9 is equal to 0. M equals 11, m equals -9. Now, I'm not crossing anything out yet because we got to test these points back at the beginning to see whether or not this actually works. Okay, so this was log 8 of 7 minus m plus log 8. What was that? It was going to be minus 5 minus m is equal to 2. Now, you usually don't care whether or not you get the arithmetic right that goes in here. We're not checking for accuracy. We're checking on which of these actually fits in my domain. Okay, one step further, would be, we're going to look. Okay, so here's my check. See, I don't want to do this one by inspection, right, because it's a little bit harder. So we have log 8, 7 minus 11, plus log 8, minus 5 minus 11. I don't like either of these two, right? This is negative. This is also negative. So I don't think 11 is going to work. Okay. We have one more, right? We have 9. We have negative 9. So we're going to do log base 8, 7 minus negative 9, plus log 8. We have negative 5 minus negative 9. Okay, this is equal to. So in this case, right, we get 7 minus a negative 9. That's log base 8 of 2. Okay, that one I like. Plus, and then we have 5 minus a negative, right? We have 5 minus a negative 9. So that's going to be log base 8 of 4. Yeah, negative 5 plus 9 was going to be 4. All right, and then claiming that's equal to 2. I don't think I like what's going on here, though, because I'm going to get log base 8. If 2 times 4 is going to be 8, that's not true. But I'm wondering if my arithmetic worked out. Oh, 7 plus 9. 7 plus 9. Okay, it's not 7 minus 9. It's 7 plus 9. Let me change that. It's a 16. And then 16 times 4 is going to be 64. And that's true. Okay, and that's okay. That's okay. So yeah, that one will work out. And the only answer we had for that one was m is equal to negative 9. And that's fine. That's what satisfied the initial equation. Okay, so we go back. We'll say there's exact solution. What did we do with this one? Negative 9. All right, so there we go. And so I kind of like that problem. It's crafty, right? It makes you check, great, but it actually goes one step further, and it makes the obvious choice, the positive number, the wrong answer. So that's a good question. All right. Well, okay, find the inverse functions. We're going to do a couple of these then. All right. So remember how to find inverse functions. This is 3 to the x minus 1. Okay, so we have x. I'll go back to below. We have f of x is equal to 3 to the x minus 1. So we have y equals 3 to the x minus 1. And then the whole point here is to swap x's, right, and y's. So we're going to say x equals 3y minus 1. And then what we're going to do here, excuse me, is we are going to solve for y. All right. So let's get x by itself here. Not x by itself. Let's get y by itself. So we have x plus 1 is equal to 3 to the y. And now what I'm going to do here is I'm going to take the logarithm of this base on both sides. We're going to say this is log base 3 x plus 1. And that's equal to log base 3 of 3 to the y. And the reason why is because when I've got this going on, that's just going to be a 1. Okay. So we have log base 3 of x plus 1. I want to try something because technically it shouldn't matter which log you've picked. So we're just going to do an alternate here. Like, what if I picked natural log and we had this is natural log of x plus 1 is equal to natural log of 3 to the y. Well, when I bring the y down, I'm going to have log base 3 here, or sorry, natural log of 3 here. Right. So ln 3. and that is equal to ln x plus 1. So I wonder if they're going to let us do this. Ln x plus 1 over ln 3. Now, if you go back to remember your change of base formula, this is going to rate, if you have log of b of a, you can pick any base you want. We'll call it base c for common of a over log base c of b. And again, this equation works in both directions. So if I look at this equation and say, wait a minute, I've got a natural log and a natural log, right? And then I can say this is log base b instead of log base b of a instead of natural log over natural log. So it technically should give me the same answer. I just want to test that out to see if it's going to insist on that or not. So I just want to see if they would rather have this or if they were okay with that. So oh no, they aren't. They don't give me the option of putting in this at all. Oh wait, let's try to sneak it through. So what we're going to have, oh, they don't give me a fraction. Oh, we can't do a fraction. Okay, they did not give me the option of doing it this way. So not only do they say, no, you can't do it, but they didn't even give you the tools to do it. So I guess that's kind of fair, because if they say you shall write it in this format, they only give you the tools to write it in that format. So that's pretty good. All right, so x plus 1, there we go. We have no other options here. So go ahead and say that's fine, and then we're done. Okay, so at least that one, they protected us from messing up. They wanted us to give it a certain format, and they only gave us the tools to put that in that format. So good. All right, find the inverse function. Okay, so let's just go in the other direction. Okay, we have f of x equals natural log of 3, or natural log of x plus 3. So we're just going to write it as y equals natural log x plus 3. And what we're going to do is swap. So we have x is equal to natural log of y plus 3. Okay. And now we got to solve for y. Excuse me. All right. So what we're going to do is we got to unlogify both sides here, right? We got to take the anti-log. So we're going to make both sides the base. Right? We're going to raise both sides. We're going to make both sides exponents to the same base. Right? So we're going to say, okay, great. This is e to the x. Remember, e to the natural log of something is that thing. And we're just going to subtract 3 from both sides and say, great, this is x e to the x minus 3. That's equal to y. And that's my inverse function. So this is e to the x minus 3. Right? E to the x minus 3. That's what I want. All right, and there we go. I don't know if we need to do another set of those or not. Actually, let's go back and look at the, let's go back and look at this one. We have 3 to the absolute value of x plus 4. Okay. All right. Oh, we're solving an equation, equals 247. Okay. These are the slightly harder ones here. Okay, there we go. So in this case, when we go back, well, actually, we're not going to have to go back and check anyway because it's an exponential function, so you don't need to check those. But both the positive and the negative side, we're going to have to deal with this. Okay, so when we get to the logarithm stuff, I'll show you what happens when you break the absolute value. So subtract 4 from each side. we get 3 to the absolute value of x is equal to 243. All right. Now, when I take the logarithm of both sides, let's go ahead and take this log. So again, this guy is going to come down in front, so we're going to have absolute value of x is equal to log of 343 over log 3. Okay, what happened here was that they had an absolute value, log 3, okay, equals. Okay, now I know absolute values are extremely difficult. Okay, I know they're confusing. It seems like the rules, like we're making this up as we go along. I completely get that. If I have the absolute value and I just put a number in here, pick any number you want, okay, that's just going to return the positive value. Right, so if I put in a natural log of like -7, that's just equal to 7. I put in a natural log of 9, it's just 9. Okay. Now, when I have an equation, I have an absolute value of x equals some number, then I have to worry about this because I've got to get the variable out of the natural log, and that's a slightly different computation. Okay. There's a slightly different process for this because you have to, I don't know what the x is. So I need to break this into two parts. I either need to say, well, x is equal to 3 or negative x is equal to 3. Because if I put 3 or -3 in here, that's what's going to make this equation true. So the only time we break it like this is when there's a variable inside of the absolute value, right? If you have x is equal to absolute value of -7, well, then x equals 7. We don't have to worry about it. But when the absolute value is around the variable, that's when we have to break it apart like this. Okay, so I know it's picky and I know it's tricky. I know it's rough. So try to remember the rule of when you have this inside the absolute value, then we have to break it into two parts. But if you just have a number in here, then we're just going to take the absolute value and get the value. Okay, so we don't have to worry about that. Okay. So here's the difference is, like, if I just wanted to say, okay, well, how long is it from Albuquerque to Socorro? Right, I think it's 75 miles. Like, I'm just going to say it's 75 miles. Where can I go? You know, where can I hit on a 2 hour? We'll say an hour and a half. Where if I can drive 30, if I can drive 90 minutes out, right? Where in Albuquerque can I get? And that way, now we have, well, if you went east, you'd have this thing. If you went west, you'd have that. If you went north, you'd have, you know, a different attraction. If you went south, well, then you'd be in Socorro. But notice that there's a direction each time I said so. Okay, I didn't say just how long is it from Albuquerque to Socorro, like 75 miles. But if I say, like, where can I go within 75 miles of Albuquerque, I've got to tell you a direction when I say that. And that's kind of what's going on here, is like, what values are you know, what possible values are three away from the 0, right? Well, 3 in the positive direction and 3 in the negative direction. You know, we don't really work with two variable things here, but if there was two variables, right, we'd have a circle. That's what's going on with that. So that, I probably botched it. I probably should have just let it go. If the variable's inside, you got to break it this way. If the variable's outside, then you can just solve it. Or if you just got a number, just solve it. Okay, but all right. So let's go ahead and do that. So we've got either, right, x equals. So we have either negative x equals log of 243 over log 3, or x equals log of 243 over log 3. Okay, so x equals negative log 343 over log 3. I know this answer is 5, by the way. You can type this in the calculator. All right. we could say log 243 divided by log of 3. Because I know 3 to the 5th is 243. We had to look that up, I think, a couple of days ago. And I just happened to remember it. So, or same process, x equals positive 5. Okay, that's our answers here. And again, I don't really care so much, right, about an exponential function because the domain is all round numbers. We don't have to go back and check. Okay. So in this case, our answer is going to be the solution set. It's a lot of power, a lot of tools to say 5, negative 5, positive 5. I do wonder if they'll let me write that as a logarithm instead, but I didn't think to ask, so let's not worry about it. If I would have come back and said, you could probably answer this in an easier way. Like, yeah, probably. Okay, 5 natural log x. And notice it's the whole thing. It's around the natural log of all the x. It's not just the x. All right. So we have 5 absolute value natural log x is equal, or minus 20 is equal to 0. So what we're going to do here is we're going to say, okay, well, this is 5 natural log x, okay, is equal to 20 divided by 5. We have natural log of x is equal to 20 over 5, which is 4. Okay, so again, we have an unknown inside of our absolute values. So we have to break it in a certain way, right? We could say that either, right, negative natural log of x is equal to 4, or positive natural log of x is equal to 4. I don't have to do too much with this one. This one, I'm going to have to go ahead and say this is natural log x is equal to negative 4. And we see natural log of x is equal to 4. Can the result of a natural log be a negative number? Don't answer yet. Okay, if we remember what the graph of natural log looks like, right? Natural log looks something like this. Right, here's the 0.10, but it does this. Okay, any part of this graph on the below the x-axis? Yeah, a lot of it is, right? Well, not a lot, but all of this over here is below the x-axis, so that's okay. So to get it out, right, to unlogify, we're going to go ahead and make each side here the exponent to the same base. So we have e to the natural log of x, that's just going to be x, equals e to the negative 4. Here, again, we're going to go ahead and do that. So we're going to have x is equal to e to the 4th. Okay, so our two answers, x equals e to the negative 4, x equals e to the positive 4. Okay, I know those are tricky. Let's see if we can do one more here. The solution set is, oh, they want 2 answers. Okay. Yeah. E to the negative 4. Technically, I'm not really done yet. I forgot to do something. It's a logarithmic equation. So these are both positive numbers though. So when I put them in here, we take the natural log of these positive numbers, we're going to be okay. What is e to the 4th? How many? 4 decimal places. Okay, 4 decimal places. So we have we need 2 things, right? So we're going to do 54.5982. 5982. 5982. Or we need 1 over e to the 4th. So 0.0183. All right. Oh, they didn't like that. 1, 2, 3, 4, 1, 2, 3, 4. Let's just double check. Should be the same thing. You're not even giving me a hint, huh? I don't know what your... let's go one decimal place out. We'll say 183, 18. Let's go with a 2 here. Let's see if it likes that. No, it didn't. I don't know what the heck there. Why was that different? Oh, because I didn't. Okay, I understand. I used the set notation when I shouldn't have. The little parentheses here. I shouldn't have put those in. Okay. I do. I do feel really bad for you guys having to tolerate this thing because this is a pain to deal with. Oh, good. This is a good one to look at too. All right. So this guy here, we have 10 to the x. It's kind of like the one we did yesterday. All right. This 13 here, can I take this 13 and multiply it by 10 to the negative x? No, cannot combine. Okay, because if I put a number in here, we'd have to do the exponent first and then multiply. So don't think we can combine these, okay? So the first thing we're going to do here is get rid of the fraction. So we're just going to multiply both sides by 3. So we have 10 to the x minus 13, 10 to the negative x is equal to 12. Well, technically 10 to the negative x is a fraction, isn't it? Right? This is 10 to the x minus 13 over 10 to the x is equal to 12. So what we're going to do here is we're going to multiply by 10 to the x. So we're going to have 10 to the x squared minus 13 is equal to 12 times 10 to the x. And again, can't multiply those together for the same reason we just did. Okay. So we're going to say this is 10x squared minus 12 times 10 to the x minus 13 equals 0. And again, I'm not sure if you're here, how far along people are with this, and it's okay, whatever step you're on to make this an easier problem for you, that's what I want you to do. So if you look at this and say, oh, I can factor this, that's fantastic, factor that. If you're here where you're going to say let 10 to the x equals a, because it makes life easier for you, we've got a squared minus 12a minus 13 equals 0. And you're going to factor this and then back substitute. That's fantastic too. It doesn't matter how you're doing this. Okay, as long as you're doing it correctly, as long as it's making sense for you, it's fine. All right, so that's okay. We have a is equal to 13 or a equals negative 1. Is that okay that I just went straight to this? Okay, and then we're going to have 10 to the x is equal to 13, or 10 to the x is equal to 4. So what it's asking is, wait, what exponent? What do I raise 10 to in order to get to 4? What do I raise 10 to in order to get to 13? Well, the answer to that question is log. All right, so this 10 comes down in front. We have log of 10. That's the same thing as natural log of e, right? It's what do I have to raise 10 to in order to get to 10? 1. Okay, equals log 13. Here again, this comes down in front times log 10. We know log of 10 is 1. And if you don't, that's okay. If you got to type this in, so this is the level you're on right now. You know, I mean, you know, I wouldn't advertise that. I wouldn't say I did it. But, you know, but if that's where you are, nobody's going to know. You're the only person that knows. So don't worry about it. You know, if that's where you are, that's what you got to do. That's okay. Nobody will know unless you tell us. So there we go. So our solution set is, so they gave me the things here, that's good. So we have log 13 and log 4. Oh, no, it's an exponential function. It's going to be okay. Oh, here's the problem. Turned into a negative. It turned into, my -1 turned into a 4. What am I doing? The handwriting is atrocious. So this should have been a -1. All right, now the graph of log 10, or the graph of 10 of the x looks something like this. Okay, -1 is not my graph. This is not correct. Okay, so none of this is good. We get rid of this one because this is not there. Okay, because we can't take the log of a negative number, and exponential function is not negative. So thank you guys for checking that out on me. Crummy handwriting. Oh, what a great question. I think I've asked this one before too. You have ln of x squared minus ln of x to the 4th equals -3. Okay. So what I'm going to ask you first before we go on with any of that, or at least I want to call your attention to this, is there a difference between this versus that? Like, yeah, there's a difference, right? In this case, we square the x and then take its natural log. In this case, we take the natural log of x and then square it. And those are two different operations. Those are going to give us two different answers. Okay, so we can't pull this 2 down in front because here we can pull the 2 down, but this is a different format. We don't have, right? We don't have a log base b of x. We don't have a rule for that. This one we have a rule for. We can pull the 2 down. But this one, can't do it. So we're just stuck with that. So that is natural log of x squared minus 4 ln x is equal to -3. All right. So again, if you can look at this and say, oh, I could just factor this, that's fine. Like, that's great. You go right ahead and do that. If you're looking at this and saying, I'm going to need a little bit more help. Well, the thing that's driving us nuts here is ln x. So this is going to give us a squared minus 4a plus 3 equals 0. And you may not need to do this. This just might give you some comfort to say, okay, I got this because I can solve this problem. That's fine. Okay, whatever your motivations are. There we go. So we're going to have, right, a is equal to 3 or a is equal to +1. And then you say, well, what the heck is a? Well, a was ln of x is equal to 3 or ln of x is equal to 1. Let's unlogify them. Right, make both sides of the exponent to the same base. So we have e to the natural log of x, that's x, equals e to the 3, or we have x equals just e. Okay, it's a delightful number. Now, we started off with a logarithmic equation. Okay, I've got to put these things back in and see whether or not they're going to work. Well, natural log of x, natural log of e, or e cubed, those are both going to be positive because these are both positive numbers. Natural log of x to the 4th here, again, both positive numbers. I'm raising them to the 4th power, both going to be positive. So I'm okay with that. Okay, so both of these checked out. right? And when you're doing your problems, right, and you write this, I'm going to assume that that's what you did, was going back and looked at it. So if you tell me you checked, I'm going to assume that you inspected the original equation with these numbers. You don't have to write them all out. Okay, I'm just going to assume that that's what you did. Unless you're wrong, then I know you lied. Okay, so this one, exact solution set is e raised to the third power, comma, and e. All right, they were happy. Why do they want us to keep writing this out? 4 decimal places. Well, 2.7182. Oh, 183. And what's e to the cubed? I don't know what e cubed is. It doesn't come up all that often. Okay. So we have e cubed. 20.085. Okay, 20.085. Where am I rounding? 4 decimal places. So 1, 2, 3, 4, 855. Looks like I can drop it because that's a 3 afterwards. 855. Oh, 4. .855, and then it's a 3, but it should be rounded up to a 4. Was it really e cubed? Is that what I typed in? It is e cubed. I didn't like it. Let's go with 3. Didn't like it. They yelled at me, saying they didn't want to do that. I don't know. I don't know. All right. By the way, well, you guys got unlimited attempts at your homework, so I'm not that worried about these mistakes with this. All right. I'm not happy about it either, but at the same time, you know, we're okay with that. Oh, I guess I closed it. Yeah, start assignment, it's fine. All right, where were we? We were like 18, 20. Yeah, we were doing something like that. Yep. All right. Actually, I'll tell you what. I'm going to go ahead and save these guys for tomorrow and call it a day with this one. And maybe we'll try some more. These are both really good problems. So we will definitely do these. You know, I'll show you these guys tomorrow. By the way, when I test, I am partial to, like, usually I like to pick the ones in the middle. But this section, I actually think the ones at the end are like a little bit more interesting. So try to make sure you're doing problems like this. I liked, what was it, number? Oh, we just did. This one, I like this one. And this one I thought was a good problem too. So, you know, 18, 19, 20, 21. We might go back and do 18 to 19 tomorrow too. But make sure you're practicing problems that look like this, because those are the problems I like to pick. All right. I know they're the slightly harder ones, but you know, they're actually, this is the usual kind of thing you're going to be dealing with. So it's good for you. Okay, I'm going to go ahead and knock off here. So for the people who are watching this as a video, have study harder. Okay, it's good. And I will see you tomorrow. So we're going to go ahead.